Hello and welcome to this DCD Talks on the journey to net zero carbon data centers. I'm delighted to be joined by Mariana Chatzopoulou, who is the Principal Mechanical Engineer at Cundall. Welcome, Mariana. Thanks for joining me.
Hi, Emma. Thank you for having me here.
Brilliant. Thank you. Thank you for joining us. So we always like to start these out with a bit of a scene setter. So you're able to tell me more about you, your career journey, and your role at Cundall.
Sure. So I'm a principal mechanical engineer in the critical systems group of Cundall. We are focused a lot on data center building design. Cundall is a multidisciplinary engineering consultancy. We have offices globally in the EMEA and APAC regions, and we are working on projects across all building sectors, but have specifically been leaders in the design of data centers over the past decade. So on my side, I'm working in the critical systems group of the London office. I have 9 years of experience in the industry, and through my career, I've also did a PhD on optimizing combined heat and power systems efficiency for industrial applications. As part of my current role in Cundall, I am a net zero carbon design advocate for the critical systems group. In Cundall, we've launched the Net Zero Carbon Design 2030 initiative, where we are challenging ourselves for all our projects to be net zero carbon by 2030, or at least have a net zero carbon design pathway with them. We know this is not an existing blueprint, and we've set ourselves a challenging target, but we're really passionate about it, and we're going to work towards this. Also, Cundall has been involved in the development of the net zero carbon building standard in the UK, and as part of that involvement, I was also involved in the data center group, that initiative. So this initiative, again, is a UK industry initiative to create a net zero carbon definition for every building type.
Brilliant, thank you. You mentioned, there's no blueprint on net zero, and we talk about net zero quite a lot here at DCD, but as a concept, it's not very well defined. So why is this a problem, and what's the Cundall definition?
Exactly, this is true, Emma. So at present, much of the construction industry is really wrestling with a clear definition of what truly a net zero building design is. And it has yet to come up with a unified methodology of how to quantify it, how to measure it. Of course, these loose definitions allow people to come up with their own interpretations and definitions and use them more like a marketing vehicle instead of using it to make a positive impact to the carbon footprint of the industry. So in Cundall, through our initiative, we really try to come up with a methodology and a definition which we will use to help our clients to get their net zero carbon status. So we've based our journey on the World Green Building Council definition of a net zero carbon building, and we've developed it to suit the data center industry. Of course, we're in the beginning of the journey, so we don't see that as a setting stone. We will see this evolving as we learn more about it. But what is key in our definition or in our approach for net zero carbon building design is that we aim to reduce our emissions first. We do that with the right site selection, design decision, equipment selection, materials. So first, we aim to minimize our emissions to the levels that are technically feasible and, of course, financially viable, and only then start considering offsets to neutralize our remainder emissions.
That's great, thank you. And I think that's really interesting what you said about definitions of net zero, and making sure that it's it's not just being used as a marketing tactic, because as you said, if you can't manage what you can't measure. I mean, a lot of the focus when it comes to carbon goes into operational carbon, which is obviously very significant, but what about embodied carbon? What's the significance there, and how can organizations manage and measure this?
Exactly. So the focus has been on operational energy and operational carbon. That was dominant. And to be honest, that was also easier to quantify. This is more tangible. So all the past years, we were focusing on improving our PUE, and our clients were looking to buy renewable purchase agreements. So their electricity use is carbon free. As we reduce our operational carbon, this is where embodied carbon now becomes dominant. But embodied carbon is a different beast. is more difficult to quantify as it goes beyond the data center site boundary. It needs a broader understanding of the embodied carbon of the emissions of the entire supply chain, which means we need to have means to measure that, monitor it, and be able to create benchmarks and then compare ourselves against these benchmarks and improve. And there are people out there that really want to get involved and do something about it, but the data is not really there yet. We've started in Cundall an organized effort to collect EPDs, PPs, or TM65 forms in the UK for pieces of plant that we typically use in the data center industry. And our civils and structures team have started doing the same for construction materials. From their perspective, it's a bit easier to find embodied carbon data for concrete, for steel. What we found is that with MEP equipment, the data vary a lot between vendors for exactly the same piece of kit. And also because the vendors are also starting their journey, the data they provide, they have a very high uncertainty. Now, in this context, we have the EU Efficiency Directive that is coming, and we'll ask very soon data center owners and operators to report their Scope 3 emissions. And really, Scope 3 emissions are embodied carbon. So they need to be able to justify the values they report when they're being audited. It is a challenge at the moment, and we really need to start moving fast, I would say.
Thank you, Mariana. Yeah, really pertinent, particularly with regards to new regulation coming out, such as the EU EED. I mean, often when we talk about AI and HPC, which was one thing that I wanted to touch on, it's often around, how much more power they're going to consume. But I wanted to ask, what are the opportunities there for reduced carbon coming from liquid cooling, and yeah, how do you see that space evolving?
So we are indeed in a period of change. The nature of data centers as we know it's going to start changing as we adopt more and more high performance computing. The rack densities has started growing already, and that will only continue. We've seen the average rack densities from being 8 to 10 kilowatt per rack today will potentially be in excess of 50 kilowatt per rack in the not so distant future. So this is a challenge for our clients because they have to adapt their facilities or future-proof their facilities to be able to accommodate high-performance racks. And clients do not know how to architect or cool or control this type of racks. So they come to us very often for support. Responding to this increasing adoption of high-performance racks, ASHRAE came in and introduced the H1 class, which is guidance for providing air cooling to high-performance racks. And the way to handle the high densities with air cooling is to lower the supply temperature. So we see the recommended temperature range up to from 27 degrees C for air-cooled racks, going down to 22 degrees C for high-performing air-cooled racks. So of course, this 5 degrees C difference, the reduction in temperature, will have a big impact on the energy consumption and efficiency of our cooling system. We will see more hours of chillers being online, or we will see more hours of water consumption if we have an evaporative cooling in the facility. Of course, this will increase inevitably energy consumption and carbon emissions. So this is why now operators are prompted to look into liquid cooling. And the other benefit we have with liquid cooling is that we can achieve the same processing capacity with less IT load because we are removing the fan power. So we're not only are more efficient in cooling the IT power, but we are reducing it at source. So we see hyperscalers already adopting liquid cooling, but we also see cooler providers coming to us and asking us how they could incorporate it in their facilities.
Yeah, no, that's really interesting to hear. I mean, you've already mentioned sort of people coming to you asking, how to integrate liquid cooling, and certainly I think we may potentially, with sort of you know, the demand for space in, you know, the tier 1 markets, I think we potentially are going to see more retrofitting. So how can data center operators integrate liquid cooling into their existing facilities? You know, what are the challenges and how can these be overcome?
So the first thing, as you mentioned, there are facilities out there already that might need to be retrofitted. Yeah. So there will be instances where we will have high density racks installed in halls that house lower density racks as well. And that will be the case for many years to come. We're not going to see a complete change from standard racks to high performance racks overnight. So the data center operators will need to be able to handle a mix of high and low density racks in the same environment. How can we do that now? How we target high density racks in this mixed environment? Direct-to-chip cold plate cooling is gaining traction as a solution because it can fit well with the kind of standard data hall and racks layout as we know it. This solution can cover 80% of the load of the rack, with the remaining 20% being air-cooled. It uses a heat transfer fluid circuit that will absorb heat from the IT component and release it to the facility cooling water system via CDUs, the coolant distribution units. The remainder 20% of air cooling that is needed will be picked up by the air-cooled facility that the traditional data center will have in place. Air door coolers or in-rack coolers are another solution. Although not strictly speaking a liquid-to-chip cooling, they can handle high densities per rack and could be partnered with CDUs if needed. Of course, there are other liquid cooling solutions available, which will require a bit more of a rethink of the data halls as we know them. We have immersion cooling solutions where the servers are fully immersed in tanks of dielectric fluids, and that can be single-phase fluid, that could be two-phase fluid. The benefit of these solutions is that they can handle very high cooling capacities. So we would be at 200 kilowatts and more, especially with the two-phase solutions. Of course, the drawback of this is that we are looking for irregular shape and forms now of these tanks. They don't look like the racks and the rotor racks as we know them. And also there have been environmental and health safety concerns around some of the dielectric fluids that are used in the two-phase solutions. We also have semi-immersion cooling options we could use where the IT components are contained in steel chassis and there is some dielectric fluid in it. The other thing to consider with liquid cooling is the architecture of the hull, which I kind of alluded to already. So in the past, we've been designing data centers all around airflow. How can we optimize airflow in the room? Computational fluid dynamic studies were done, trying to identify hotspots, try to find the best cold aisle widths to accommodate good velocities in the building. With liquid cooling now, we don't really need all that, especially if we're talking about a new build facility. There will be no return air ceiling voids, there will be no supply voids or underfloor supply system. So that would be a completely different design of the data center. Of course, in retrofit installations, this is where we may end up with a lot of empty space because now we use less racks for exactly the same IT load. So what can we do with that empty space? Would there be opportunities for getting additional electrical infrastructure potentially and increase the density? These are the things we will start seeing a lot. And I think the last thing I'd like to point out here, which will work in our favor, is the higher operating temperatures of liquid cooling technology. We will be able to expand our free cooling window because we will be having temperatures up to 40 degrees C, which means we will have free cooling not only in the Nordics area, where we had it for a few hours of the year already, but even in milder climates or even in the tropics. So we can switch off our compressors for so many hours per year or consume less water if we have an evaporative system, and overall improve our PUE and our energy consumption. So there are definitely opportunities that come with these challenges, and as an industry, we will see this coming our way.
Yeah, absolutely. I mean, the other thing that I wanted to touch on with regards to opportunity is waste heat recovery. I know you've already touched on the Nordics. Obviously, this is something that's more widespread here, but with countries such as Germany potentially legislating to say data centers have to reuse X amount of heat. What are the opportunities there? Because I think often when we think of waste heat recovery, it's only on a large scale, but there are sort of smaller scale opportunities there as well.
That's a great point, Emma. Data centers can become part of a circular economy and give back to the community. And we've seen already data centers, we've designed data centers that are connected to heat networks. For example, one of our projects in Denmark heats thousands of homes in the nearby town by being connected to the local district heating network. Also, in that region, we're seeing that the planners are asking for the data centers to be able to connect to a local heating network in order to get planning permission. And we see a similar trend like in the GLA here in London, where the data centers need to be heat recovery ready, at least. So we've been supporting our clients to come up with solutions to integrate heat recovery, either in their template designs, if they have some, or come up with new designs that could incorporate heat recovery. We have examples where we've integrated heat recovery in direct fresh air systems, where the heat recovery coil is being used as another cooling coil, replacing a chill water coil, or reducing the number of hours that we're using an evaporative cooling pad, for example. We've also looked into integrated heat recovery in chill water systems, where the heat recovery coil is used as pre-cooling to the chiller. So we run the chiller less hours per year. And going back to the liquid cooling technology we were discussing just earlier, with a higher return water temperatures from liquid cool racks, this means that the consumer of the heat can achieve better efficiencies in their heat pumps. So it's a kind of win-win situation there. There's definitely opportunity here, and I believe in the future we will see more and more applications where data centers will be part of a heat network of some sort, or of an energy network of some sort.
Thank you, Mariana. Great to hear more about those waste heat recovery opportunities there that can help with circularity. Unfortunately, we are almost out of time. I wish our conversation could have gone on longer. I know that Cundall are writing a series of articles for our website, so anyone who wants more information would urge you to go and have a look at those, and of course get in touch with Mariana. But Mariana, any closing remarks, any key takeaways for those watching?
Sure, yeah. The move towards achieving net zero carbon is gaining traction, actually is here, and it's all of us in the industry. It's not just about the designer, just about the owners, just about the vendors. Everyone has a role to play in achieving a truly net zero carbon data center.
Brilliant. Thank you so much, Mariana. Great to speak with you, and hopefully we'll have you back for another DCD talk soon.
Very much, Emma.